Good afternoon, everybody. Good afternoon, everybody, and welcome to this session organized by the Earth Observatory of Singapore. So my name is Lauriane. I'm the Community Engagement Manager at EOS. I'm a former volcanologist, so I used to study volcanoes and moved towards science communication a few years back. So I'll be your host for today's session. So today I'm going to show and basically engage with you about how we at the Earth Observatory of Singapore promote safer and more sustainable societies. So the session is divided in two parts. The first part, I'm going to be talking about what we do and, how we basically try to make society safer and more sustainable. And the second part, we'll be playing a little game together. So, and after that, I'll be answering any questions you might have. So to start with, why do we have an Earth Observatory in Singapore? So basically, you can see on this map, there are a lot of different hazards that surround us. So the different colors and the different icons, they basically represent different geohazards that threaten our region. So in red, you can see seismic hazards, so you can see how much earthquake are likely to affect these different parts of the region. So the redder the area, the more likely you will have strong shaking in these places. In the orange triangles represent the huge number of volcanoes we have in the region. So basically all across Indonesia and going up to the Philippines towards Japan, and then we will have the Pacific Ring of Fire, if you're familiar with that. In gray and black, we can see the hazards due to storms and cyclones. I mean, you probably hear in the news a lot. There are many different cyclones affecting Philippines. Mostly we've heard recently in the news. So you can see in black are the lines where basically some possible tracks for cyclones. And in gray, you can see where basically most of the cyclones were happening. And finally, in blue, where we can see a lot of our coastal regions have a little blue tinge, basically delineating areas that are vulnerable to sea level rise. So with climate change happening quite fast, a lot of our coastal communities are being threatened by rising seas, mostly due to the melting of the ice sheets and the expansion of the ocean as the temperature increases. So basically you can see Singapore, we are almost right at the middle of it all. So here we don't have much, we don't have many hazards, but we are surrounded by them. So at EOS, what we want to do is to build capabilities to understand, mitigate, and respond to these hazards and disasters. So we try to doing that, we hope to make our societies more sustainable and resilient. So this is our mission. So at EOS, we conduct fundamental research on earthquakes, volcanic eruptions, tsunamis, and climate change in and around Southeast Asia towards safer and more sustainable society. So we are a research center of excellence at Nanyang Technological University. So we basically conduct a lot of scientific research that hopefully meets the needs of our societies and improve the lives of people around the region. So how do we actually do that? So to try and help societies, we have we use a very kind of defined approach. So first off, we need a lot of data. So you could see on this map, there are a lot of things happening in the previous map I showed, there was a lot of different hazards happening. So first off, what we do is that we monitor all these things. So we have a lot of stations in the region. So on this map, you can see different again, icons representing different stations. So the different colors represent different types of instruments. So I'm not going to give you a crash course on geography, but basically what's happening in the region is we have a lot of different tectonic plates moving in the region, creating a lot of earthquakes and creating volcanic activity. So we have all these stations to monitor all these movements. For example, we will have GPS, so same that you will have on your phone. Same instrument, except if you anchor it in the ground, it will monitor how the ground moves. So we have a lot of these stations all around the region and monitoring also earthquake activity. So through our Center for Geohazard Observations, which is the team which basically collect all this information, we get a lot of different data to understand the functionings of the region. We also have an EOS remote sensing lab, which is using remote sensing data. So basically satellite data that come, from many different satellites around the Earth and sending data. They basically image what's happening on the Earth. So using these techniques, we try to respond to disasters as soon as possible after they happen. So what happens, for example, after a disaster, a strong earthquake would be that buildings are damaged or buildings have collapsed. So using this technique, using satellite imagery, we can map out where those buildings are. So hopefully this can help, humanitarian assistance. So we are doing this both for buildings that have collapsed and also places that have been flooded. So using satellite imagery, we can better inform where the affected areas are. So these are I mentioned two of our flagship labs. And here, basically, in the next 4 slides, I'm going to present to you very briefly all the different questions we're trying to answer to help, make society safer and more sustainable. So basically, the Tectonics Group, we have a lot of scientists studying earthquakes and how the tectonic plates move. They would use the GPS data, they would use information about earthquakes to understand, where are these earthquakes happening? Are they big or are they small? Are they happening between where the 2 tectonic plates meet? Most likely, yes. So where could this earthquake happen and how big can they be? And also the associated hazards such as tsunamis, because earthquakes can cause large tsunamis. We have a volcano group that really looks at all that's happening within a volcanic system. So everything starts underground where there is magma, coming up and trying to erupt. And this is creating a lot of signal in the volcano. So we are looking at what drives the eruptions and how can we better forecast these eruptions as well as the risk for societies. The climate group, they have a very holistic approach to try and understand using different types of data, for example, measurements of sea level rise, what is driving this sea level rise? Is it the melting of the ice sheet? Yes, of course, but there are also a lot of different processes that are happening, for example, in Singapore and other places in the region where, the land can sink because in some parts of the region or in the world, we might extract some water, for example, from underground and the soil sinks. So there are a lot of different processes that can drive how much sea level rise we will have. And finally, the last group we have is the risk and society group. So a lot of our scientists are trying to bridge the gap between all the science that we do and how we can have societal impact. So they are basically looking at, given all this I've been talking about, like sea level rise, how can we find solutions? So for example, using nature-based solutions such as mangroves or coral reefs to protect our coasts, looking at our economic vulnerability and how we can change and reduce that so then we are less vulnerable to disasters when they happen, and how this, of course, changes with time so that societies can keep benefiting from our research. Finally, I wanted to mention briefly, this is the gap to the next session. So that's the work of my team. So I'm from the community engagement and education team. So we basically try to bring the science out of the lab. So we work a lot with different stakeholders, different audiences, may that be the general public or students before they reach uni. We try to raise awareness on earth sciences, geohazards, and so on. And we engage a lot with the media, different partners. So we want to basically promote a safer and more sustainable future. We work with the Ministry of Education of Singapore to improve the curriculum of the secondary schools, and we constantly have ongoing projects to basically co-create, things so that we know that they are being used and helpful. Okay, so that was my very short introduction of EOS. the next thing I wanted to do with you was to play a little game. So I understand there will be, you are all connected to a Slido. So on the Slido, you will be seeing in a few seconds, there will be polls that will be shown. So we will use polls to play this little game. So first, a short intro. So we're going to play one of our dynamic Earth games, which is a series of games that we created as an educational tool to communicate key ideas about disaster preparedness and acting in uncertainty and enacting evacuation plans. So basically, we have a bunch of games, 7 games, that range from card games to very large sets. So on the photo here, the one on the left, you can see a very large game, which is called SimCity. It's basically a full-size, not a full-size, but quite large game that we play with different people. You can see on the photo, for example, these are secondary school students. So right now, these games are hosted at the Science Center Singapore, where they can be played as part of workshops, because there are a lot of discussions going on around those games. So we want usually to have a facilitator around to help discussions and, drive things around. These are not games that we are selling right now, but if you have any questions, feel free to contact me and we can see how we can, maybe, I can bring those games to you, try to organize some sessions. So basically the goals of these games is basically threefold, or even more than that, but at least threefold. First, we want to help people understand the hazards that can happen in a region. Where are they, what causes them? Secondly, we want to help students and people to understand and assess risk. So risk is a very important aspect of making society safer, because it's only when we really understand our risk that we can make informed decisions and try to reduce the risk, so we are less prone to being hurt or having our house being destroyed and all this. And finally, the third goal is to explore the challenges of evacuation. Basically, when there is a hazard coming to you or to communities, they have so many things to think about, such as, do I have pets to take care of? Do I have elderlies in my family that I need to bring with me? Am I scared that things will be stolen from me if I go away? So there are all things that people always constantly, not always, but might think about before they can evacuate. So I'd like to put you a bit with this game in this kind of situation where we're going to role play being, a community potentially affected by an upcoming disaster. So the game we're going to play is called Too Farm, Too Furious. You can see here some photos of workshops where we played with students at Science Center Singapore. So basically, it's a very simple game where we are farmers. We are all farmers. So we're going to be part of a family because we can't play every single one of us. But basically, these are 5, you can see on the photo, 5 different farms, right? The one on the right is not as nice as the one on the left is not as nice as the one on the right. So as you know, most of us would like to do, we want to improve our life. We want to get a better house. So that's going to be the point of this game. We're going to try to get to a better house with time, knowing that we live in a volcanic region, potentially threatened by volcanic eruptions. So the game is going to start like, okay, we're going to start off as an average farm. So the objective of the game, as I mentioned, is going to be the first. So in that case, we're going to be the same family, but we want to reach the best farm as we can. So we're going to explore topics related to probability, acting in uncertainty, and also role-playing or imagining how it could be to live near volcanoes. So the game, so we're going to slightly adapt it for this session, but just the game in general. Each farmer, so each family, starts at the middle. So we start at the average farm. At each turn, so there will be a few turns, I will give, so there will be a scientist or somebody telling you that there is a certain probability of the volcano erupting. So let's say, for example, 65%. And then each family, so in that case, each one of us will have to decide, given this probability, are we evacuating or are we staying? So this is a lot of, so basically this is mimicking scenarios that are happening in a lot of the places, usually governments would help you to decide whether to evacuate or stay, of course, but this is just to put you in this mindset of, okay, I have 65%, it's not 100%, it's not 0%, what do I do? So this is basically the game. And then, of course, depending on the choice we make, there will be consequences. So let's say we start in the middle farm, I give you 65% of eruption. If there is an eruption, so if you evacuated, so let's say the first one, the first row, if you evacuated, there is an eruption. That's fine, you are safe, right? It's just you evacuated for a little while, and after a while you come back to your farm. It's a bit damaged, but that's okay. You can start growing your vegetables and make money again. If you evacuated though, but there's no eruption, so we're still on the first row of the table. There's no eruption. Basically, you evacuated for nothing. So basically, next time you come back, maybe usually when there is an eruption, the government will help you. If there's no eruption, the government might not help you to rebuild your farm. Therefore, you move to a less good farm. So you move to the left. Let's say you decided to stay. Of course, if you stayed and there is an eruption, then your farm is destroyed. So basically, you're eliminated from the game. So hopefully, we can play a few rounds before this happens. And if we stayed, but there's no eruption, then we can continue growing our vegetables and we can move to a better farm. So I hope everybody got the game. It's a very, very simple game. So we're going to play a few turns to put you in this mindset of acting in uncertainty. So let's play. So we're going to play, because of this online platform, we will play as one big family. So that's why the poll that I mentioned earlier is going to basically gauge your answers so that we know whether we evacuate or stay. So we will start, of course, on the average farm. So at each turn, so we'll play 3 turns, depending, hopefully we don't get eliminated the first turn, but we'll play 3 turns and see where we go. So I will draw a probability of a volcano. So basically, how that works, I have this ball here, which is full of 100 balls. Each ball has a number on it. So you can see here, here is 91. Okay, so basically when I say in the example, there is a probability of 65% of the volcano erupting. Here I have 100 balls. If ever I draw at random a number between 1 and 65, then it's a positive outcome, meaning the volcano erupts. If the number that I draw is above 65, then the volcano didn't erupt. Okay, and depending on that, we will know whether we made decisions on the right decision on evacuating or staying. Okay, so we're going to start. So this is a photo of the usual setup. So I actually have the farms here, but given the online setting, we're not going to play, but just wanted to show you this is what they look like. So we usually set up those farms on the table and decide on first which vegetable we want to grow. So I understand I didn't make a poll for that. So we can choose eggplant, we can choose corn, and we can choose onion. So if you don't mind choosing, I will choose the eggplant. That's my favorite vegetable. So let's say we take eggplant. So I'm going to put, oops, sorry. I'm going to put, okay, I cannot put it. Okay, so basically I'm going to, we're going to start. Let me reshare my screen. So then I can share the editable version. If you don't mind, I will share this one. Okay, so we are on this slide. What I'll do is I put my eggplant here, the average farms, as I said I would be doing. Okay. Next off, and that's when we're going to use the poll, okay? So be ready. The scientist is basically telling us that there is a 39% chance of the volcano erupting. What would you do? So that's the poll starting. So if you go on your Slido, you can choose, given the probability that I gave you, do you choose to evacuate or stay? So I will give you a few minutes, or maybe 1 minute, to 1 or 2 minutes to answer. I hope everybody can see the Slido on the poll section. And you basically need to tell me, given a probability of 39%, would you decide to evacuate or stay at your farm? Okay, I'll give you a few more minutes to answer this question. I mean, obviously, it's all subjective. People have different risk perception. People have previous history. So it's all normal that we have different answers, especially when we are like in this 30, 60% probability. So there's no right or wrong answer in the end because it's all probabilistic. So it's okay. Don't worry about what you say. Just give your best bet. If you were in this situation, what would you do? Okay? Okay, so I guess we can close the poll so we can do a few more rounds. So I can see that most of us chose to stay. Yes, 67% of us chose to stay. So what I'm going to do now is draw a number here. If the number is between 0 and 39, that means that the eruption happened. If the number I draw is above that, the eruption didn't happen, okay? So, okay, so the number I draw is 75. I hope you can all see, okay, 75. So that means the eruption didn't happen. So we're in that case where we stayed, the eruption didn't happen. So we can move to a better farm. Okay, I hope you all got this. So my eggplant, which was here, I'm very happy. I can keep growing my vegetables. I didn't evacuate. So now I'm in a better farm, okay? So I hope you all got how this works. Very, very easy. We're going to play a few more rounds so you can get to experience different situations. Okay, so all is well. Of course, you're living in a volcanic area. It's not very, sometimes, you know, you get a lot of information coming from the different agencies, and you've been growing your eggplant for a little while now, and suddenly the volcano which is near you decides to show a bit more activity. So the scientists are telling you, okay, it's a bit more this year. It looks like there is a 68% chance of the volcano erupting. So can we launch the second poll? And I will let people decide what would they do in that case when there is a 68% chance of the volcano erupting. Would you decide to evacuate or would you decide to stay? So there is a new poll in the poll tab for you to provide your answers. Okay, I'll wait a few more seconds for you to give your estimate or you give your choice. And then as a family, we'll decide either to evacuate or stay. I can see a strong, strong preference for this one. Okay. So I guess there is a clear answer. I mean, perhaps more of you want to answer, but clearly, as a family, we feel that we should evacuate. The number is way too high, 68. It's not worth staying and risking the eruption to damage us or our family. Okay, so I'm gonna draw another number, same thing. So again, if the number is between 0 and 68, that means the volcano erupted. If the number is above, that means the volcano didn't erupt. So random draw. 17. So in the end, the volcano didn't erupt. Did erupt, sorry. The volcano did erupt. So because we evacuated, there was an eruption. We are safe. That's the first thing. And what happened is that we evacuated, but the government is helping us come back to the same farm we were before. So we stay, where we were, here. Okay, and now we're going to play a last round. So I hope you can still see my screen. Yes, looks like it. Okay, so we're going to play a last round. Basically, similar thing. You're back to your farm here. You start growing again your eggplants. You start making money and so on. But the year after, the volcano is a bit less active. So that's fine. It decided to, there was less activity. The scientists decided, okay, the probability of having an eruption is decreasing. And this time they're telling you it's about 37. Okay, so same thing. And one last round, and we see where we are at the end. With 37 probability, and there is a new poll in the poll section, what would you do? Would you evacuate or would you stay? So there is a new poll in the tab, and I invite you to give me your choice, so then we can know what to do as a family. This one is actually very tricky. It's a bit like the first one, very tricky to... All right, I'll give you a few more seconds. So again, given this 37 probability of an eruption happening with the potential to harm your family, and your farm, what do you do? Do you decide to stay or to evacuate? Okay, I can see now it's a bit more balanced between the two options compared to last round. Okay, but I can see actually most of us still feel that we should stay, okay? So that's actually, you can see how staying can have, actually can be quite dangerous, because if the eruption happens, we just lose the game. But I think it's quite brave. We decided the probability is low enough. We've learned from the first round that we made, actually from what we've experienced so far, we were pretty, our decisions were the right ones given the outcome. So I think we feel quite confident, and this time around we decide again to stay. So final round, I'm going to draw a number. Again, if the number is between 0 and 37, the volcano erupts. If it's above that, it doesn't erupt. And the number I draw is 16. So that's when we were too brave, because the volcano erupted. All right, so I know you can't speak to me, but basically that means we stayed. There was an eruption, so basically we lost. So basically that's how the game works. So basically we're eliminated from the game. Usually how this works is then we would, there would be several players, so then we can join other families and start again. But you can see how overconfidence can basically make us lose. Okay, so I hope you kind of, I know it was a bit short, and usually it's a bit more interactive. I have actual props to play with, but I hope it gave you an insight about those tools that we use to basically engage communities and try to also help them become safer and more sustainable, alongside our research that are meant for more policymakers and media. So that's the end of my presentation. Thank you very much for participating to the activity. I hope you had fun. And now until the end of the session, so that's about 10 minutes, I'm happy to answer any questions you have. Thank you. So I'll stop sharing my screen. So the questions can be asked in the Slido, as I understand. So I will, please type anything regarding our science, regarding careers in earth sciences in Singapore and abroad. So as I mentioned, I'm a former volcanologist, so I can answer a lot of the scientific questions as well. Or if you have any question regarding how we conduct engagement activities, whether you would be keen to have one, anything that you can think of, I'm happy to answer. So just type them in the Slido. Or for example, it can be just a comment whether you liked the game or not. It's also very nice for us to have feedback, whether there could be things that we can improve in the game, whether, you know, anything. Okay, so I have a first question, which is how to predict volcanic eruptions. So that's a very good question. So how basically, in the game, scientists were giving probability for an eruption. How do they actually know that? So there are a lot of things that scientists can do to predict eruption. So again, predicting eruption is the holy grail. We're not quite there yet. We try our best to understand what's going on at a volcano. We can warn communities, a bit like the game we played with giving probabilities, but it's not a prediction saying, okay, this volcano is going to erupt tomorrow at 10 a.m. We are far from being able to do that on a very efficient way and everywhere. So basically how we do to know how to predict eruption is to basically understand the status of the activity of the volcano. So I mentioned we collect a lot of data, right? In the beginning of my talk, we collect a lot of data in the region, and that's actually not unique to us. We work alongside monitoring agencies in Indonesia and the Philippines and other countries to maintain those stations that can help these agencies better understand what's going on. Because a volcano, by its state, when the magma is going to try to come up and erupt, it's going to create a lot of different signals in our stations. It's going to create micro earthquakes. It's going to cause the volcano to deform. It's going to have a lot of gas coming up. So basically all these signals we can record, and we can learn how we can understand how they evolve through time and whether this is becoming more likely to have an eruption or not. So basically we use all these monitoring signals to understand and better forecast eruptions. Okay, so that was the first question. Second one would be, how do you do public engagement and promote awareness in people in volcano or tsunami prone areas? Okay, so that's also a very good question. So I mentioned we collect data with our monitoring agencies in Indonesia and the Philippines. We basically also work with them to, prepare content, inform them about our ongoing research, so then they can go to their communities, because it's usually better when it's the local agency approaching communities rather than, doing parachute science or these kind of things where people abroad, they just think they know better than you and they just, tell you what to do. So it's always better that it's a monitoring agency from each country. They know much better what to do. So we would usually work together with them, and they would approach the different communities and inform them about the science. They would have different ways. So sometimes they would have, if there is an impending hazard, they would have sirens, they would have early warning systems. So we're just here to really work together, and they will do the management part. I hope this answers your question. Okay. Thanks for the feedback about the game, interactive and fun. That's always nice to hear. Okay, so I have a comment about the game and how we can, if I have any advice on how to develop such games to explain scientific concepts. So scientific concepts is actually a bit broad, but how can I, so the probabilities could be a scientific concept. So for example, probabilities for me for a very long time were very hard to understand, but I think using this game very easy, hand-on, I think is very key. Actually, probably an advice is to make your game very hands-on, where people can play with things and understand by themselves how it's working. So I mentioned those games, we are playing them at the Science Center in Singapore. We actually have an exhibition there, which is meant, these are not games, but they are very interactive exhibits where people can just play by themselves and understand the concepts instead of just like reading things on a panel or in a textbook. So I guess having something very, very interactive is key. Yeah. So another for public, thanks for the creative idea with the game. Do you have other suggestions for public outreach that you found have been successful and engaging? Definitely. So, and we get more and more of these engagement requests, and I think people are more and more, I get so many requests to do citizen science. So people want to basically be involved in the research. They want to contribute to the research. So I think this is very key. Like what I mentioned before, co-creating things with communities is definitely more efficient than just telling them what to do or just like talking to them about what we think is better, but it doesn't relate. So I think what we've been doing recently over the past few years is really to work together with communities and trying to involve them in the research process. Such examples include attachment programs. So for example, we have a few students or teachers who came to work with us for a while, and we just create content together that they know they need and that can help them. We do that with students for similar things. And citizen science would be more so when they come and help us with the research. So basic stuff, for example, 2022, last year, we had an earthquake in Sumatra that caused shaking in Singapore. So basically what happened is that a lot of people reported feeling shaking due to the earthquake. So what we did after that, we basically released a poll survey where we wanted people to tell us about their experience, how much shaking did they feel, and so on. And that helped us basically do our research. So actually we have preliminary results that we would like to present next month. So I will promote this event on the social media channels from the Earth Observatory of Singapore. So basically we want people to know what we've done with your data. So I think this kind of engagement activities are key. So thank you very much. Sorry, I couldn't answer all the questions. I'll see with the organizing committee whether I can get them and maybe find a way to answer the others. Otherwise, feel free. You can find my email address on the Earth Observatory of Singapore website. Please feel free to reach out with any question, any ideas on how we can work together to promote a safer and more sustainable future. So on that note, thanks a lot for joining this session. I hope you learned a bit about the research we do and how we're really trying to make a difference. And I hope you also had fun trying to role-playing how it is to potentially live near volcano. So thank you very much. And I hope you enjoy the rest of your day and the rest of the event. Bye-bye.